Hi everyone. So today we're gonna continue to evaluate this integration using numerical method. Okay, so to solve this integration, to solve this function by integration technique, numerically we can use trapezoidal rule and we can use midpoint. These are the numerical methods. We can also use Simpson rule. Okay, you need to watch my first video on numerical integration where I've shown how to solve a simple integration using these three methods. But today we're going to look at something called composite rule. Okay, so let's look at this function here. Fx equals to square root 1 over x squared dx. Okay, let's say I want to integrate this from a to b. Square root 1 minus x squared dx. Now, integration here means finding the area under the curve. Okay, so let's say this is the function you have. Okay, this is my function here, my fx. Okay, yeah, I've shown you if we're using trapezoidal rule. Okay, so we can find the area by using trapezoidal rule. This is my A interval AB. Okay, we can see here the area that we obtain by using the trapezoidal rule are not fully covered. Okay, there's some balance. Okay, so your solution will be not accurate. However, we can divide this interval into n sub-intervals. Okay, you can divide this into n sub-intervals. Okay, we can divide this into n sub-interval. So x1, x2, x3, up to xn, which is my xb. So that's what we're going to look at. Composite rules here, meaning for this interval from a to b, where my a is my x0, b is my xn. So I can divide each of these interval with this step length called h. So I can have x1, x2, x3 up to xi minus 1. Xi and xn minus 1, where h is given as b minus a over n, and xi equals to a plus ih for I equals to 0, 1 up to n. Okay, in other words, my integration here becomes summation I from 1 to n, integrate from xi minus 1 to xi fx dx. Okay, so by using this n interval, so you can get three methods. I'm not going to show the derivation here, just going to show you what are the methods. So we have composite trapezoidal rule, okay, which can be written as integration from xi minus 1 to xi fx dx, which is equivalent to b minus a, you know, the basic integration. So xi minus 1 f of xi plus f of I minus 1, and then let's write it properly. Formula is very important so that you don't make mistake. So I need to write this clearly. Okay, so where is it? Okay, so f at xi minus 1 plus f at xi divide by 2. Okay, this is recall the this is actually your trapezoidal rule without n subinterval. We have b minus a f of xa plus f of xb over 2, right? Now if we are dividing into n subinterval, okay, so we can write this as Tn equals to h over 2 fa plus fb plus 2 of summation I equals to 1 to n minus 1 f of xi. Okay, now h is b minus a over n, so we have b minus a over 2n fa plus fb plus 2 summation I equals to 1 to n minus 1. xi is a plus ih, so I can have f a plus ih. Okay, so this is my composite trapezoidal rule that you can use. Okay, so if I have T6, where I've divided, if n equals to 6, I can divide it into 6 intervals. So I have b minus a over 6 times 2, 12, fa plus fb plus 2 summation I from 1 to 6 minus 1 is 5. Okay, f of a plus ih. Okay, or I can we know x a is x naught, so this is what we know. We know a is x naught and b equals to xn. Okay, so T6 is given as b minus a over 12 f of x naught plus, okay, don't forget f of xn, which is my x6 and the 6, plus, now everything else in the middle from x1 to x5 you will have to multiply with 2 times f of x1 plus 2 times f of x2 plus 2 times f of x3 plus 2 times f of x4 plus 2 times f of x5. Okay, so this is simple equation that you obtain for n equals to 6 using composite trapezoidal rule. Okay, now I can go fast now, so you get the idea. So composite midpoint rule also can be obtained if you divide the subinterval for n subinterval given as mn equals to b minus a over n summation I equals to 1 to n f of a plus 2i minus 1 h over 2. Okay, so this is composite midpoint rule. Now we can also have composite Simpson rule. Composite Simpson rule given by Sn equals to h over 3 f of x naught, which is my xa, plus f of b xn plus all the odd number you multiply by 4, f of x1 plus f of x3 plus and then times by 2 for the even number, plus 2 times f of, just make a big thing here. Okay, this is f of xn minus 1 plus 2 times f of x2. See all the even number multiplied by 2 plus f of x4 plus f of xn minus 2. Okay, so if you're not clear, let me give you for n equals to, so for instance, if n is 6, I have S6 h over 3, and then we have f of x naught. So if I have x6, so we have x naught, x1, x2, x3, x4, x5 and x6, so we have 6 interval. Okay, so x0 and xn, okay, xn is x6 plus 4 times all the odd number, which is x1, x3, x5. So 4 times f of x1 plus f of x3 plus f of x5, and then plus 2 times the odd number, the even number, which is 2 and 4, f of x2 plus f of x4. Okay, so this is Simpson rule. Okay, so I hope on my next video I will give you some example. I don't have much time to continue to give the example for composite rule, so maybe you can try at home. So evaluate this interval cos x dx. Okay, use composite rule and see which one gives close to the exact solution. Okay, so that's all for today.